Hello everyone. In this session we will talk about very interesting cases where latency in SQL Server queries come from missing indexes. Let's get started. Okay, let's start our session with the first scenario. Okay, so this is a very simple select query where you can see I'm selecting two columns with a count, and I'm just doing two simple join operations. Okay, very much simple query. Let me make it a little bigger. Okay, so let's try to run this one. Okay, I will enable execution plan actual one and live execution plan and run it. Okay, so you can see now, since I enabled live execution plan, I can see what is happening currently, right? In flight. Okay, it is going on. Okay, now you can see it finished within 11 seconds. Okay, so let's check whether we can improve it or not. First of all, what I will do is I will right click on this select and click on properties and go to I will go to execution plan, not live. Okay, go to actual one here, execution. Can you see this execution plan? Right click, go to properties and click on query time stats. Okay, click on it. Now you can see elapsed time, the whole query time, and CPU time, right? You can see in the whole query time, CPU time is big. So it means our query is mostly running, and there is no any kind of major resource contention like I/O, memory. There is no such kind of thing. If you want to check it more properly, you can go to show execution and plan XML and go to wait stats here. Can you see wait stats? Wait stats will show us until now what kind of resource we waited and how long. Okay, so scheduler yield means CPU we waited. As you can see, it is major wait time. Then memory, we waited how long? It is milliseconds, 37. Then I think network IO we waited, page IO we waited, right? Very, very small number, right? Compared to this 10, 11 seconds, these are small numbers. Okay, so therefore from here we can conclude that this is no memory issue, or this is not there is not any kind of IO issue. If there would be big numbers here, right, something like 000, something like that, then we would say, oh, I think there is some kind of IO issue here, right? But here there is not such kind of issue. The major thing, major wait we are waiting for is CPU. Okay, and it means we should fine-tune this query by using execution plan. Okay, so here you can see our execution plan, and from here execution plans. Okay, from where we should start. Okay, first I will quickly pay attention to these warnings. Warning, right? To see the warning, you go to properties and go to here, warnings. Okay, it is saying columns with no statistics. Okay, columns with no statistics. So this is a warning. If you click on it, you can also see warnings here. Can you see warning? Columns with no statistics. It means this column is without statistics, and we should create statistics. Okay, this is the first point. Second point is I will pay attention to this table scan. Table scan. This is interesting, right? So table scan is usually a costly operation. Why? Because we scan the whole table and process the whole all of the rows. Okay, if I show you this one, for example, right click on this, go to properties, and can you see table cardinality? This is a whole number of rows, right? All the rows. And you can see the number of rows I'm processing is 33,150, and all the rows I have is 33,150. They are equal. It means I am reading all the rows, and table scan means that. Okay, table scan is very much costly operation. Table scan happens when you don't have indexes. Okay, if you see table scan, in most cases, this means you should create index, and this is a improvement point. Okay, so that's good thing. Okay, we found out 2 points, right? First, create index, create statistics. Then second point, most important point, guys. Before doing any kind of troubleshooting or fine-tuning, pay attention to the statistics. Okay, so what is bringing my attention is these two numbers. Can you see? Let me do like this so that I can show these two numbers. Can you see? 1000%, 345%, 1000%, 1000%, right? What does it mean? It means we are making mistake in prediction. Okay? If you click on table scan, right, and go to actual number of rows which you are processing and predicted number of rows which you predicted, it is a huge difference, right? 10 times more. Okay, 10 times more. So therefore, the 10 times the more, right? You compare this one and this one. So therefore, it is, instead of 100%, it is becoming 1000%. Okay, if this number, estimated number, if it is equal to actual number, then you would have 100%. But in this case, we are making huge mistake in predicting the actual number. Okay, the actual number should be something like with 0, but here we are making mistake. Okay, this highly indicates, if you see, let me summarize this one. So if you see huge difference between actual number and predicted number, right? Predicted number, you should update statistics. Okay, here you should update, here you should update, you can see, right? And here 100%, it is good. Here, good, because you can see our prediction is matching with our prediction, this one is matching with actual number. So it is 100%. This is good. Okay, but this number is very much different. And you can see it is also impacting to the next operators. You can see hash match is making 300. Let me also again 345%. Okay, this is impacting 1000% is impacting here, and it is also impacting here, impacting here, impacting here, impacting here. You can see, right? Big percentage numbers. All of them is ideally should be 100% or close to 100%, but it is not. So this means that we should first also update statistics, right? So our findings from here means first we should create indexes and omit table scan, right? Second one is update statistics, right? Update statistics. And so third one is create any non-existing stats. Okay, here you can see warnings, right? Non-existing. 1 point. Okay, if you create index here, this automatically stats are also created. So therefore, this one and third one is nearly the same. Okay, because if you create index, this will be also created. Okay, so therefore you can just remove it. Okay, so we will deal with this in the first step. Okay, this is the things, and now, okay, now we have initial steps. Okay, we will see improvement point after creating index and updating index. First, I will always start, usually, okay, always you should do update statistics. What I will do is I will just simply, very much simply run exec sp update stats. Okay, and go. I'm running this in my DB, and what does this sort procedure does is it will update all the statistics in my DB. Okay, I will disable execution plan and let me update it. Okay, so I started to update, right? You can see output. Yeah, very much useful, right? Updating which statistics and how that happened, right? So some stats you can see did not require update. Okay, but some stats was updated. You can see all here has updated. Okay, there are some stats updated, there are some stats did not require update. Okay, this sp update stats, this will do it automatically for you. Okay, so now we updated statistics, right? Now let's see again the performance. Let's see the performance. Okay, I will again enable execution plan and run it. Okay, so it was 11 seconds before. Okay, let's see how is the improvement. Oh, now it improved to 9 seconds. Right, let's see. Okay, why it improved is you can see now we SQL Server started to predict correctly. You can see 100% here, right? 100%, 100%, 100%, 100%, right? Hash match aggregate is usually like might make a little bit mistake. So mostly 100% prediction is correct. Because of this correct prediction, you can see hash match, our operators also change it. Right? Good. Now we improved. After updating statistics, we improved. Okay. What is the further improvement point? Further improvement point, you can see we should create indexes, right? So what index to create and how to find that target indexes? Okay, you can see missing index here, information. If you click on here, not here, sorry, right click here, right click, and where is that? Missing index details. If you click on here, that the SQL Server is suggesting this one. Okay, you can also go ahead like this, but I will tell you the tricky point, how to choose indexes. So indexes are very much crucial usually during join operations. Okay, always indexes is very much important while doing join. You can see we are doing hash match join, right? In both cases. Okay, if we are doing hash match, so we should create indexes here. Okay, while reading data. Okay, so for what column we should create, right? How to create it? To answer that question, I will pay attention to my query. Pay attention. I will a little minimize it, right? I will minimize it. Then what I will do is, first I will pay attention to this table scan. Why? Because can you see that runtime stats? Let me do that. Can you see the runtime stats? It is 4 seconds. Can you see? 4 seconds. Others are 0.0 or something seconds, but here it is 4 seconds. It means from 9 seconds, 4 seconds SQL Server is is spending for this table scan. Okay, therefore I target my index creation for this table scan first. Okay, so what is this column and how to create index for this, right? For that, what I'll do is I will right click, go to it is properties. Okay, then I will come here and scroll down and click object. Okay, in this object you can see here properties of this. This is database name and index kind heap. Okay, this is table name. Oh, it is invoices. It's also written here, right? So it is invoices table. Okay, it is invoices table. Okay, and I will look at my query. Okay, here I'm doing join here. Invoices. Okay, invoices. Yeah, hash match join, right? Join and invoices. Okay, I found it. So here, what kind of columns are being used? You can see for invoices, right? I'm using customer ID. Or now I found it. So it means I should create index for customer ID to change this table scan to indexing operation. Okay, so let me show you. What I will do is I will go to my database. Okay, I will use UI for you to make it easy for you, but you can also use T-SQL. I will go to perfmondb, then go to tables, then I'll go to invoices, right? Invoices, my table. Then I will expand this one and will refresh. There is no any index currently. So what I will do is I will right click, new index, clustered index, non-clustered index. It depends. But if there is no clustered index, right, you should mainly create first clustered index. Okay, so I will click on maybe let me show you non-clustered maybe because this is invoices, right? This is not customer, so I will create non-clustered for this. So non-clustered and click add. Okay, then I will click on customer ID. Okay, click OK, right? Because I'm here using customer ID, right? So perfect. Then I will generate a script, right? You can also click OK, of course, but I prefer script. Okay, let me show it a little bit more clearly way. Let me make it a little bit smaller. You can see here I'm using perfmon. So for invoices table, I'm creating index by using customer ID. Perfect. Now click on execute. Okay, let's wait a little. Okay, we created. Now I will click on new query to so that I can compare later the result. So I will run this query again. Okay, copy and paste. Okay, let's run our target query again. Okay, let me make it a little bit more beautiful way. Okay, this is execution plan. I will close it. I don't need this anymore. So I will run this again. Okay, I will enable execution plan, live and actual one, and run it. Okay, let's wait a little. Okay, 4 seconds, 5 seconds, 6, 8, 9. Oh, it became a little bit time consuming now. Interesting. So 16 seconds. Interesting, right? Oh, I see. Even if we created index, as you can see, index are not being used for some reason. Interesting. So what I will do, I will continue creating index. first I created index here, right? In invoice. I will also create index for this customer table, table. Okay, why? Because this customer ID is being matched with this customer ID. Okay, so what I will do is I will also create index for customers. Indexes, right click, index, and the clustered index this time, because this is customer table, customer ID. Click OK. Click OK. I don't need script this time. Okay, so now I created index. Let me run it again. Okay, run it again. Oh, okay. I see. Here we go. There are some changes we have, but our query is taking a long time. Okay. Here you can see customers table, right, changed from table scan to clustered index scan. Can you see? Right? So now we are not doing table scan anymore. Okay, but there is no improvement. Actually, our query got bad, right? Let me actual one. So here you can see our changed. Okay, so I will continue. What I will do next is I created index for this join column, and also there is orders table. And in this orders table, there is also customer ID, right? So what I'll do is I'll expand orders and create indexes also there. Okay, what I'll do is I will create non-clustered index and click on add and customer ID. Click on OK and click OK. I create index for this table. Okay, let's wait. Okay, now let me try to run it again. Please remember this table scan, clustered index scan, right? Now let's try to run it. Here we go. Okay, this time our query finished very much fast, but only 9 seconds, right? There is improvement, but there is 9 seconds still. Okay, 9 seconds still, but interestingly, very much interestingly, we are still, this table scan is not changing to index, right? We changed this one to this to index, this one also index, you can see, but table scan is not changing. Okay, why it is not changing? I will try to understand that one. Okay, let's try to understand. Okay, first I'm doing join between customers and orders. Orders and customers. Okay, here. Okay, this hash match join is this one join, right? And invoices is this one, right? This one, but you can see still SQL Server is not utilizing index. Why? I have a problem. Have to find. Okay, for that I will go to here. Here. Object here. Object output list. Let's see. Object. Performance roster invoices. Did I make somewhere mistake? Why it is not changing actually? Invoices, right? Refresh. Invoices. What was this actually? Properties. Customer ID is also here already. Oh, here is a very much good suggestion SQL Server is giving. Okay, I will try to do that. Okay, missing index details. What is SQL Server is doing? Oh, I see. Confirm delivery time. SQL Server is saying, oh, create index, of course, with customer ID, but also include confirmed delivery time. I see. Why this is happening? Okay, let me explain you. Okay, let me close this one. Why this is happening is, if you pay attention to output of this table scan, output, there are two columns, customer ID and confirmed delivery time, coming from this table scan. Okay? Output. Okay? Output of this table scan is these two columns. It means if we create index, including index like this, let me show you. New index, non-clustered index, right? Click add, customer ID, right? This first column, customer ID, then included column, include confirmed delivery time. Okay, confirmed delivery time. Oh, where is that? Oh, confirmed delivery time. Let me. Okay, come on. Confirm. Yeah. Receive time. Confirmed delivery time. Where is that? Confirmed. Do we have that? Here. Okay. And click OK. So included column, right? Then like this, it is saying, okay. So I'm making main column, this one, and this one including column. Okay. Okay, good. Let's try to create it. No worries. And okay, it might take a little time because my table is big. Okay. Okay. Now let's try to run it. Please pay attention here. Pay attention. It's very much tricky point. It is table scan now, right? Okay. Maybe I will make it to another action. Okay. Okay. I will try to execute now. Let me try to execute it. Here we go. Here we go. It became, or it improved to 6 seconds, guys. 6 seconds, we are improving. So now compared to this, right, to 9 seconds, it was table scan before. Now we improved these indexes, we improved our query by changing this to index scan, right? Okay, compare this table scan, it changed to index scan after we create index. Okay. Okay, very much good. Very much good. Okay, is there any improvement point? View the improvement point. Okay, you can see here 6 seconds, right? 6 seconds. We are spending where? 4 seconds here. 4 seconds, right? To these operations, and the hash aggregate and remaining other seconds is here. It's very much. I'm not seeing any further improvement, any warnings anymore. We created indexes, we improved a lot. How can we further improve this? What I can suggest here is, if you face such kind of issue, try always whether you can improve it with parallelism. Okay, why I'm thinking parallelism is a good choice here is because you can see here this one, right? Hash match. And the hash match is, if you click on this new query, properties, okay, and let me do this here. Okay, hash match. If you do this properties, go to properties, and you can see actual number of executions, right? Only one thread is working on this huge data. Okay, only one thread. But what if we divide this work among different threads, parallel threads? Can we improve it? What I will do is I have currently max degree of parallelism equal to 1. Okay, I will go to properties, go to processor, where was that? Advanced. Go to here, max degree of parallelism. I will make it 0 so that SQL Server can use unlimited one. Let's make it 4 only. 4 only, so that it becomes feasible, right? 4. Okay, so it means I can use 4 threads instead of 1 thread here. 4 thread parallel threads, and I hope that if 4 threads work in parallel, they finish the job faster. Okay, I will change it to 4. Okay, then let's compare the timing. Okay, I will copy this and let's run it again with degree of parallelism. Okay, I will show you interesting thing, guys. Look, pay attention. Click execute. Here we go. Here we go, guys. Can you see? 2 seconds. 2 seconds. Why? Because if I showed here again, here I showed, if I show this one, right? Again, go to properties, and if I show here actual number of rows, you can see 4 threads are working at the same time, right? 4 threads. So they, instead of 1 thread, 4 threads worked in parallel, and it made our query faster. Okay, so you can see it was only 1 thread before, right? Only 1 thread here, and now it became 4 threads. Okay, so this can show us how important it is to configure also max degree of parallelism, and parallelism also can help us to improve our query. Okay, so I hope that you found this scenario useful. Let's switch to another scenario. In the second case, I will talk about a little bit more complex query. Okay, so in this query, you can see I'm using with operator. Okay, with one, and again with, then and I'm bringing the data from these 2 with. Okay, let me make it a little bit smaller for you. Okay, so with, okay, select query inside this with, again select query again in another with, then finally select query. Okay, so this is the query I'm running now. Let me run it. Okay, and I have been told that this is also taking a little bit time to complete. Okay, for that, first I will include actual and the live execution plans and run it. Okay, it started. Let's see how long it takes time. So I can click on results, any kind of messages for any error. Okay, everything's going well. So here we go. So it finished within 15 seconds. Let me, this one, 15 seconds. Okay. So, okay, if it finished 15 seconds, what did we do? First, I will click on again, right? Starting point, go to properties, go to query time stats, and I can see most of the time SQL Server is spending on CPU. This means we don't have any resource contention, and we should concentrate on fine-tuning the query by using execution plan. Okay, if you have small CPU time, something like 14 or 144, something in this case, you should look at what kind of resource we are waiting. In this case, but a CPU time is big, so we should concentrate on fine-tuning the query. Okay, so let me show this query. Okay, so I will go to right side always, okay, and try to understand. Okay, again, I can see table scan, right? Table scan, table scan, table scan. Okay, this is the improvement point I will consider. Okay, I might need to create index. And second point is sort. Sort, guys, please always remember, sort is very much costly operator always. Okay, why? Because sort is like, let me explain. For example, if you bring data from here and you sort data here, right? Until sort finishes, data cannot flow to another operator. Okay, therefore sort is costly, and sort is also CPU intensive and memory intensive. Therefore, as much as possible, try to get rid of sort. Okay, sort usually happens when there is a merge join operator and when you use order by. Here you can see I'm using order by, right? In such kind of cases, sort is used. Okay, so here sort is being used because of merge join. Okay, merge join only works with sorted data. Therefore, SQL Server first trying to sort data, doing some compute scalar operator, then doing join. Okay, this join, okay, coming from which part of our query? I will tell you. So order lines, right? Order lines. Where I'm doing join, order lines here, right? Order lines and orders. Order lines and orders. This join. Okay, this is becoming to merge join with sort. Okay, so okay, I got it. No worries. So what is this problem here? Why? And look at the pay attention to the warning. Warning is saying operator used tempdb to spill data during execution. That is very bad, guys. Okay. So what does it mean is because of lack of memory, SQL Server used tempdb disk to temporarily sort data. Okay. As you know, disk performance is has always latency, right, compared to memory. So therefore, if you have more disk latency, this sort become more time consuming. Okay, therefore SQL Server always tries to give you warning. Oh, be careful! I'm using disk. Be careful about this, or something like that. Okay, this warning is related to that. So let's try to get rid of this sort and to get rid of this tempdb spill. How to do that? For that, first of all, what I will do is, so try to understand first of all why sort is being used, right? In this case, sort is being used because this data is not sorted. Okay? I will repeat. This sort operator is being used because this data is not sorted. Okay? If we sort this data, this operator will be omitted. Okay? And here also the same. This sort is being used because this data orders table. Orders, right? Can you see? Let me here again. Orders. Can you see? Orders. This data is not sorted. So therefore SQL Server has to sort it by itself. And yeah. So here also order lines are not sorted. So how to sort them? Okay. How to omit this sort? So the first thing you should do is, the best way to sort data is creating index, clustered index. Okay, so this table scan, right? This sort. First of all, sort uh, is being ordered by what column, right? What column? It is table name and order ID. Can you see order ID? So sort is being this data, this table scan order lines, right? These order lines are being sorted, by using by using this this column order ID. Okay, column reference. Can you see? And this sort is referencing also order ID. Okay, this means if we create clustered index by using order ID here in this table and here in this table, then we will be able to sort data and we will be able to omit these sorts. Let me show you. So I will go to order lines first. Where is my database? It is perfmondb 22. Okay. Okay, order lines, right? Order lines and orders. So I will create first order lines. Let me show you. It's very much interesting, guys. Index, clustered index. Okay, then order ID. Order ID. Okay, good. And I'll create it. Now let me show you. Let me show you. Let me compare it. Okay, it's very much interesting. So I will add it a bit like this. Copy in another session. Let me show it to you. So execute. Okay. So see, we created index here, right? Clustered index by using order ID. See, or there, can you see improvement? 7 seconds now. Okay. So if you go to here again, now there is no any order line. Where is that? Order lines here. Now you can see there is no any sort. Can you see how our query improved with just one index, right? Compared to previous case, let's compare. Huh? In the previous case, there was sort. Here. Sorry, here there was sort, right? But we created index and sorted this data. So therefore, SQL Server is omitting sort here, and our query improved, right? From 15 seconds, our query became 7 seconds. Can you see? Now, next one is what we will do is I want to omit this one also. Let's omit this one also. Orders, right? Orders here. Orders. Okay, it is doing some kind of compute scalar, and okay, here sort has been omitted because now we are using hash match instead of merge join. Okay, so let me create index also here. Index. Let me do this first. Okay, so this hash match is happening, right? It's which part it is between customers and orders. Customers and orders. Let me do this. Customers. Okay, here. Customers table. Okay, and all this is orders, and this is like hash match. It is becoming now, right? Hash match. This one, hash match. So to improve this hash match, what we can do? We can create index for this table and this table. Okay, so let me try for customers table. Since we are using customer ID right here, I create index with customer ID, and for orders also, for orders I'm using customer ID. Okay, so I should create index for this column in orders and for this column in the customers table. Okay, let me do it. So customers, I will go to customers, indexes, new index, clustered index, and click on add and customer ID. Okay, so because you know that, right? For join operators, when you use join, you had better create index for these columns and customers and orders also. Let me create orders for orders here. Let me create a refresh and a new index. Orders non-clustered, and click on customer ID and click on OK. Click OK. Okay. Now try to. This is 7 seconds now, right? Let me copy this once. Copy this in new query to compare, right? And try to run it one more time. Okay. It was 7 before. Come on. No improvement. Oh, it's a little. Even latency increased. Very bad. Very bad. Why it is increased? It's 1 second. But oh, here it's still orders. Still, we are using table scan. That's not good. That's not good. Let me do one thing here. Okay, table scan. Orders are using table scan still, right? And it is taking 2 seconds. What we can do is output list from this order ID, customer ID, and order date. Okay, order ID, customer ID, and order date. Okay, so let's so these 3 columns are going out, right, from this table scan. So let's try to create one including index, like new index, non-clustered index, yeah, for order ID. Okay, and I will include other columns like customer ID and order ID. Customer ID and order date, order date, yeah. Okay, no worries. So I'll create it. And let's try to run this time, how it improves. Let's see. 4, 5, 6. Oh, 8. This time also 8. Let's see. This time also 8. Okay, now it became index scan, right? And the cost is 0. It improved a lot. So, but where we are, here, sorting. We are spending time here, sorting. Because we have order by close here. Okay, sorting for by which column it is. Let me try to find it. Order by. Oh, this 1, 2, 3, 4. Okay. Sorting we are doing. Then index sick we are doing. Okay. I see. Okay. So I think this is what. To summarize, what we did is our performance was 14 seconds before. Then by creating indexes, we improved it by to 8 to 7, between 8 and 7 seconds. All right. Now, any improvement point is I'm considering it. I'm not being able to find any further points to be honest. Let me live the execution plans. Any point, guys? Any point? Let me do this. Okay, any point? Okay. Okay. I think there is not so much we can do here. Okay, string aggregate we are doing. Okay, no worries. One more important thing. I just noticed one thing here in my query. I'm using format. Okay? Format actually it's very, very bad because if you use formatting, it might cause slowness in SQL Server. Okay? I don't like formatting, to be honest. So in this case, what we can use is this is like formatting it as YY months months, right? Okay. So what we can do is if you do order formatting, a little bit fine tune our query. Okay. What I'll do is I will. What we can do, what operator we can use is, let me try this. Let me try. Instead of format, I will use another date from from parts. Okay, date from parts. We will use year. Okay, and as or order date. Okay, and months is s or order date. Okay, and I will do one, I believe, and s order months. Okay, so in this way I'm going to omit this formatting. Okay, I don't like it, and let's see how it improves. Then after that, group by. Here, group by close also, I'm using the same thing. So I will just copy this thing here, date from parts. Okay. And I think now should be okay. Order by, group by. Okay. Okay. And let's check the performance. Okay, I think let's try now how long it takes. Okay, 7, 4, 5. Oh, okay, 7 seconds currently now. Okay, 1 second improved. 1 second. So it's good. Good. What do you think? It's very good. 1 second is also can be important point. Okay. So in this case, you can see first what we did is we created important index, omitted sort operators, right? Before, do you remember? It was sort operator here. We created a clustered index and omitted sort. And secondly, what we did is uh, we changed the data format and omitted format column. Okay, and after that, not so many things we did. I think then we have been able to improve our query 2 times. Now currently our query is 7 seconds. Okay, so this is how we troubleshoot our queries. So, and let me summarize our learnings. This is a summary of our learnings from 2 cases. First, table scan is comparatively time-consuming operator. Try to change it to index operators like index scan and indexing. Second, try to create indexes on columns which are being used in join clauses. Third, degree of parallelism is a good option to further improve queries. 4. Including columns in indexes might further improve queries. Fifth, sorts are costly. If you create clustered indexes, data is sorted and you might be able to remove sorts. And finally, formats are costly in queries. Okay, so please do not forget to like this video, share it, and do not forget to subscribe. I very much appreciate your time because I'm spending a lot of time to prepare this session. And please keep watching. Thank you.